In this video, we're going to be talking about counting methods. We're doing this in the probability section because for certain probabilities, we have to be able to have a systematic way of counting up the number of options or the number of ways something can happen. So we're going to look at a few different scenarios. There's three main counting methods that we'll be talking about here. The first is what's called the fundamental counting rule, or sometimes this is called the multiplication rule. So here we have how many 4-digit PIN codes are possible without repeating digits. So the way we want to approach this, I like to think of this as we're picking 4 different digits. So I have 4 sort of slots that need a number. So we can say, all right, how many options do we have for the first digit? Well, there are 10 different digits between 0 and 9, so there would be 10 options here. And then we say, okay, well, how many options are there for the second digit? Now, if we're not allowed to repeat digits, which is what our problem says here, then whatever we used for the first digit, we can't use again. So now there's only 9 possibilities remaining. For the third digit, we've already used 2, so now there's only 8, and then 7 for the fourth. Now, what the fundamental counting rule says is that if we want to know the number of possibilities to put together all of these 4-digit PIN codes, we're going to multiply each of these numbers together. So 10 times 9 times 8 times 7, and that will give us the total. You can think of this as if you pick your first number, there's 10 different options. You could think of branching off 10 different times. That's not quite 10 here. But then for each one of those, say we pick 0 as the first digit, there are 9 options to go with that, maybe 1, 2, 3, etc. But if our first digit was 1, there are still 9 options. So we get 9 for each one of these. The total number of possibilities at this stage would be 10 times 9. And then for each one of these options, we'd have 8 more, and then 7 branching off of that. So there's way too many branches to draw, but we can still compute this by using this sort of multiplication method. So if we compute this, we end up with 5,040 different possible PIN codes. If the digits can be repeated, we're going to do the same kind of operation. We're going to say, okay, we still have to pick 4 different options. There are 10 choices for the first, still 10 for the second, 10 for the third, 10 for the fourth, since we can still reuse digits here. So this would be 10 times 10 times 10 times 10, or 1 with 4 zeros. Or 10,000. So if you're allowed to repeat digits, we end up with about twice as many PIN codes. Another example that would fall into this category, we want to know how many ways could you answer a 10-question multiple choice test if each question has 4 possible answers. So again, I want to think about what would we be picking here. So if you were actually answering the multiple choice test, there are 10 questions, so we can think of this as 10 different slots. And then for each question, for each sort of choice that we're making, we want to know, well, how many possibilities are there? Now, since each problem has 4 possible answers, we would have 4 options for the first, 4 for the second, 4 for the third, and so on. These are all going to be 4s. Now, instead of writing this all out, again, use your math skills to your advantage. This is going to be 4 to the 10th power, right? 4 times itself this many times. If our multiple choice problems had different numbers of possible answers, maybe some of them only had 3 choices, we could do the same thing, but maybe we'd have a 3 in here. So 4 to the 10th, or just over 1 million possible choices. So we certainly wouldn't want to list all of these out, but we know how many there are using this counting method. So think of this method as making slots for each choice or selection you're going to make, and then how many options do you have for each one. We're sort of treating each piece separately. In the calculations that we're doing here, we're doing a lot of things where we're multiplying numbers times one another. So something that's going to come in handy is a mathematical notation called factorials. And the factorial is this exclamation point after a number. So here's our definition. N factorial is the number n times n minus 1, n minus 2, and we keep counting down all the way to 1. So if we have, for example, 6 factorial, this means 6 times 1 less would be 5, 1 less would be 4, 3, 2, 1, and it would be that product. So 6 factorial comes out to 720. 12 factorial, same thing. We're going to have 12 times 11 times 10 times 9. I'm not going to write all these out, right? We see the pattern here, and we get all the way down to the bottom. So you can imagine as these numbers get big, factorials become very, very large, and it's handy to have this sort of shorthand notation instead of writing out a big, long multiplication like this. We're not going to do a whole lot of computations with factorials, so I won't worry about computing this out. We could certainly type all this into the calculator. Your calculator also has a factorial option that you could use, but I'm not going to worry about that here. One thing that we often end up doing with factorials is dividing them, and this is a pretty important operation. So 7 factorial divided by 4 factorial, we have to think of this as 7 times 6 times 5 times 4 times 3 times 2 times 1 on the top, and then we have our 4 factorial, 4 times 3 times 2 times 1 on the bottom. So you'll notice that because the 7 factorial starts at 7 and goes down, it actually has a 4 factorial in it, which means that whenever you divide factorials like this, you can always cancel something. In this case, we can cancel the 4, 3, 2, 1. So what we end up with is sort of part of a factorial, 7 times 6 times 5. If you remember the first problem that we did, when we did the pin codes where there was no repetition, this would actually be a partial factorial. You could write this as 10 factorial over 6 factorial if you wanted to. So this kind of computation is related to factorials. Just as a comment, 1 factorial, of course, we start at 1 and count down, so this is just 1. And 0 factorial is defined to be 1. So this is just a definition. It doesn't really follow the pattern of the rest of this, but if you see a 0 factorial, that's just 1. All right, the second method of counting is called permutations. And a permutation is an ordering of distinct objects. So we're taking some things and putting them in some kind of order. The notation that we use here looks like N capital PR, where the N and the R are sort of little subscripts or a little lower than the P. And this is our formula. We'll look at how this calculates out in just a second. This would be the number of permutations or orderings of N objects taken R at a time. So this sounds pretty weird here, but let's look at an example. So here we have 10 runners in a race. We want to know how many possibilities are there for who's going to take first, second, and third place. Now you could actually do this problem with the fundamental counting rule, but we're going to do this with a permutation. So what we've got here is we have 10 objects, or in this case they are runners, and we're going to pick 3 of them, first, second, and third. So we're taking an ordering or a permutation of 10 different runners, but we're only picking 3. So we're not ordering all the runners from first to 10th. We're only ordering those first 3. So this would be 10 permute 3. Or when we compute our formula, this would be 10 factorial divided by, this would be 10 minus 3, or n minus r, so this would be 7 factorial. Again, when we compute this, remember that 10 factorial really means 10 times 9 times 8 times 7, etc., divided by our 7 factorial. And of course we want to cancel these. It's great if you can cancel them without actually having to write them out, but we're going to have a few numbers left, 10 times 9 times 8, and that product is going to be our answer. And this comes out to 720 possibilities. If we wanted to know who took first, second, third, and fourth places, right, we could do something like 10 permute 4. Or if we wanted to know how many outcomes there were for all of the runners, taking them all into account, we could do 10 permute 10, etc. A related method of counting is called combinations. You'll notice that the notation here looks similar. It's got the N and the R, but instead of a P for permutation, we're using a C for combination. The difference between permutations and combinations is that permutations are orderings. We're putting something in a particular order, whereas in combinations, the order of the items doesn't matter. So I like to think of these as groupings. So we're taking a group of n things taken r at a time. So when might we want to use a combination? Here's an example. We have Annette wants to choose 3 of her 6 closest friends to be her roommates. How many options does she have? So we could set this up as a permutation as this sort of 6 permute 3, but this is not going to work here. The reason being is that with a permutation, we're talking about ordering the 3 people she picks. So if she has 3 friends, say Alice, Betty, and Kathy, then we would have one possibility for Alice, Betty, and Kathy, another for Alice, Kathy, and Betty, another for Kathy, Alice, and Betty, etc. Now these are really all the same group of roommates, so since we don't really care what order she picks the roommates in, we don't want to count these as all separate possibilities. So this is the case where we would use a combination. This looks the same. This is 6 total people. We're choosing 3 of them, and the order doesn't matter. For computing this with the formula, we would use our 6 factorial over 3 factorial times 6 minus 3, which in this case is 3 factorial again. Once we cancel, you can multiply these things together, or you can cancel some more common factors. 3 times 2 itself is 6, so I could cancel a 6, and then the 1 doesn't really matter. So this ends up as 5 times 4, or 20 possibilities. Couple practice problems here. So here we want to find how many 5-card poker hands are there. So I'm thinking of this as saying we're going to select a group of 5 cards for our hand. I'm going to do this as a combination or permutation, because we're selecting 5 from a total of 52 cards. So there's 52 cards, we're picking 5 of them, and then the question is, should this be a combination or a permutation? And again, our difference is, do we want the order to count or not? Now in a card hand, it really doesn't matter what order you're dealt the cards, because you can always rearrange them if you want. So since the order doesn't matter here, I would use a combination. Now our formula would tell us that this is 52 factorial divided by 5 factorial times 52 minus 5, or 47 factorial. Now you could definitely compute this out with the formula, but I also want to show you how to do this on the calculator. So on your TI-83 or 84, we can have the calculator compute combinations and permutations. So we're going to enter it in sort of like the notation is here. We're going to have the 52 first, and then our combination, and then 5. So I have to type in 52. Then the combination is in the math menu, this button on the left-hand side. We're going to go all the way over to probability on the right. And you'll see there's an NPR and NCR option, so we want our combination option. So 52 NCR, and then we do our 5, and then it'll just compute that out for us. So you certainly can just do your computations on the calculator. You don't have to do them with the formula, but it shouldn't matter. You'll get the same answer either way. Here's another example. Your company has to select 7 people to serve on a task force. If you have 14 people, how many possibilities are there? So again, we have a total of 14 people, and we're selecting a group of 7. So this is going to be either a combination or a permutation. And we want to know, well, does the order matter or not? When we select people for a task force, does it matter who we pick first, second, third, fourth, fifth? In this case, no. This is just a group of people. So again, we would do a combination here, and then we could just compute this on the calculator or using the formula. One more example. Your same company has to appoint a president, a vice president, and a secretary, as well as a 4-member advisory board for a new division. How many possibilities are there? So this problem is a little bit more complicated because 3 of the people that we're picking have individual jobs, but then we're also picking a 4-member advisory board. So I want to think of these as in 2 different groups. So the 4-member advisory board, in this case we're just selecting 4 people, and the order doesn't make a difference. So this is going to be a combination. with our president, vice president, and secretary, you could compute this with the fundamental counting principle, or if we're thinking of this as a group of 3 people, this would be a permutation, since it does matter who is president, who is vice president, and who is secretary. So we're picking 3 people, but the order of the pick does matter. So in the previous problem, it said that there were 14 people in the office. So here we're picking 14 people in a permutation, and we're picking 3 of those. In our 4-member advisory board, assuming we've already picked the first 3 people, there's only 11 people left. So now there's a pool of 11 people to choose from. And we're going to pick 4 of them. And again, this is a combination, since the order of the advisory board doesn't make a difference. Now to put these together, we've got 2 different choices that we're making here, so we have to multiply them with our fundamental counting rule to get our total. Now I would probably just do this on the calculator, but you could do it with the formula. So I would do 14, use the permutation option from the probability menu. So 14 permute 3 times 11 and then our combination 4, and we get our answer. So this is sort of a tough problem because we've got 2 different counting methods, or really 3 different counting methods all combined. All right, here's some for you to practice. For each question, decide whether you're going to use a permutation, a combination. You could use both if it's a combo, or neither. Some of these you could just do fundamental counting principle. Then compute the number of possibilities. There might be more than one way to compute some of these, so that's okay. And that's it for this video. See you next time.